the periodic table. So we talk about that for a couple of days, and then we're going to get into something called periodic trends. And that's what the majority of the chapter is kind of centered around. Okay. So periodic table is today, this is going to be more of a history lesson than anything. Okay. So when we first started with a periodic table, every time. There we go. It was back in the late 1800s, and we're going to watch a video tomorrow on kind of some of the development of this and how they figured out how this was created and that sort of thing. But Mendeleev was looking for a way to kind of organize the elements. So they started to find a bunch of different elements. They were starting to isolate these and identify them, give them names and symbols. And they were starting to work with them in different chemical reactions. And they needed a way to kind of organize them so that they could, be able to determine different things that were going on. Okay. Just makes it easier to work with when you got everything organized. As many of you have found when you try to locate something in your backpack or your bedroom or your car. If you don't have it organized, it makes it a little difficult, right? So he was the one that came up with this. There was another couple other people that were doing the same thing at the same time. They pretty much organized them on properties, reactivity, so how they react with other things. So if we put a match to it, what's it going to do? If we, heat it up, what's it going to do? The formulas for those compounds, so when this reacts with this, and what ratios does that happen? And then atomic mass, so how heavy the thing is. Okay, so those were things that he was looking at. Each of his elements he had in a particular column, and those had similar properties. And our periodic table today is set up in the same fashion. Okay, we talked about the noble gases, for example, and how they don't react with other things. Okay, that is a property of those elements, and it's all similar. He also, and this is what gave him kind of the title of being the father of the periodic table, is he left gaps in his table. And he said, we haven't discovered an element yet, but I'm betting it's out there and it's going to have these specific properties. And he nailed it. And we're not talking about just one or two. Like there were like 5 or 6, and he nailed every one of them because he was able to go, when we find this, it's going to have this property, it's going to be approximately this weight, it's going to have this type of, it was incredible the way he did that. Okay. So he left gaps in certain areas, and then those things, once they were discovered, they filled them in and they exactly matched. So it's kind of cool. So he's considered to be the father of the periodic table. Okay. So our first group as our first column on the periodic table, excluding hydrogen. Hydrogen is not, I'm jumping up and down and screaming at you right now, okay? Hydrogen is not a metal. It is a gas. It is not a metal. Good. Everybody got that? It's solidified. Even though it's in the first column, it's not a metal. Why is it in the first column? You should know from last chapter. First column all have what? One what? They all have this in common. They have one. What? Nope. Valence electron. Very good. They have one valence electron. I was going to play hangman with you. They all have one valence electron. So that is why they are in the first column. That is why hydrogen is there, but it is not a metal. Everything else in that column is a metal, and they're known as alkali metals. And you might have heard of some of these every once in a while. They'll talk about alkali metals in terms of batteries. These are common in batteries. You'll hear like lithium batteries and stuff like that. Okay. So lithium, sodium, potassium, they're all going to react vigorously with water. You're actually going to do a lab on this next Friday, okay, where you add these to water and see what happens. You get a very, very small amount of them, by the way. A lot. Go out and YouTube videos of people throwing a big chunk of this like into a lake or something. It is crazy. Metal hydroxides are going to be formed when they are put in water. These things are called bases, like sodium hydroxide, for example. Okay, they're bases. They make a basic, as opposed to an acid. They're bases. They have to be stored in water, in oil, because oil and water don't mix. And they need to be in oil so that it doesn't mix with water, because it reacts vigorously with water. Okay. And when we get this in, it's in, the metal is stored in oil. Then it is in a plastic bag and tied. Then it's in a metal can that contains essentially kitty litter. Okay. And then that's sealed. I mean, it's like a crazy amount of stuff that they do to ship this stuff to us. Why do they put it in kitty litter? What does kitty litter do? Merritt? Right. It'll suck up the moisture and not allow it to get to that metal. Okay. Because that can be a very bad day for that trucker if his whole cargo starts to catch on fire. Okay. All right. So, these are the types of batteries. The lithium batteries are the types that they won't allow you to have in your checked luggage in the airplanes. Okay, you got to have them up above, because if they catch on fire, you can do something about it. Okay, it's not going to take the whole plane down, you hope. Some guy actually had his one of those quick chargers in his backpack, and it caught on fire on a flight a few weeks ago. So they used the fire extinguisher to put it out. Huh? Why did it catch on fire? I guess it probably got too hot, I'm guessing. Sometimes those quick chargers, I mean, you've had your phone charged before if it's wireless. Even if it's not, it gets pretty hot. So yeah, those are the types of batteries that they don't allow underneath.
Oh, lithium batteries?
Yeah.
Oh, yeah.
Okay. We can actually cut these with a knife. So when I give these out to you, I actually have just an old kitchen knife that I cut them with. Lithium's a little harder. Sodium's almost like butter, and potassium, it's like melted butter almost, like right on the edge of being melted. I mean, it just like shoop right through. It's crazy how easy it is to cut through them. I mean, as opposed to like normal metal that you're used to, like in faucets and stuff like that. The freshly cut surfaces, when I cut them, I want you to look at them. They'll actually be shiny, but they start to react with the oxygen in the air right away. And so that's why they end up with a film over them before long. So it's kind of interesting. So you'll see that in lab. All right, the next column over, again, these are pretty common in batteries as well. These are the alkaline earth metals. We're going to be putting magnesium and calcium in water next week so that you can see what they do. Beryllium doesn't really act with water, so we don't do anything with that. They're going to form with the water, they're going to form alkaline hydroxide, so magnesium hydroxide, barium hydroxide, that sort of thing. It's fine, yeah. All the alkali earth metals then have 2 electrons in their valence shell. They tend to lose those 2 electrons, and therefore they have a +2 charge. Okay. Transition metals, these are in the D block of your periodic table. Those elements in the D block, and these are ductile and malleable, which means that we can pull them out into thin wires. Malleable means that we can pound them out into thin sheets like foil. And they also conduct heat and electricity, like copper wiring that you have. Okay. Basic metals, then, these are just kind of called basic metals. That is your aluminum, your gallium, indium, tin, thallium, lead, bismuth. And they are considered basic metals. They are the ones that are not in the D block, but they're still in the metal category. Have we talked about the stair-step line on the periodic table? Okay. So they're the ones that are to the left of that stair-step line that are not in the D block and are not in the S block. They tend to be pretty dense and they're opaque. What does opaque mean?
Isn't that like cloudy? Almost?
Yeah, you can't see through it. Okay. As opposed to transparent. Okay. I would say that translucent would be cloudy, and I would say that opaque is you can't really see through it. So translucent would be like a lot of shower doors are translucent, like you can't see through them, but it still lets light through. Opaque doesn't let light through. Make sense? Okay. All right. Metalloids then are the ones that touch that stair-step line, and not the points of the stair step, though, the actual line. Okay. Aluminum's considered other metal, though, because it tends to be more metallic than it is a metalloid. Our halogens, then, are going to be in the second to last column next to the noble gases. And you might have heard of halogens. They used to have halogen lights. I don't know if they're still producing those or not. They may be for like cars still. Most things have switched over to LED now. But when they were trying to move away from like the light bulbs that we had when I was a kid, they moved to halogens for a while. And now they've kind of moved on to LEDs because it tends to be a little bit better technology. So halogen means salt former. And anytime you have these, they're going to react with stuff. They're never usually found at all on their own. Solid forms then iodine and astatine. Bromine is a liquid. It's one of two liquids on the periodic table. There's only two liquids on the periodic table. What's the other one? Anybody know? The other liquid on the periodic table other than bromine.
Nitrogen?
Nope, it's a gas.
Mercury?
Mercury, yep. Okay, they used to use those for thermometers. I still have an old mercury thermometer at home. They work really well. But the problem with mercury is the vapor is poisonous. It's hazardous. So when you break a thermometer that's glass, you release this mercury into your house, and it's supposed to be toxic. So that's why they moved away from them. But they worked so well. So if you've got an old mercury thermometer, look at that thing. Can't get them anymore.
How are you not afraid of breaking?
Because a little bit of exposure. We actually, when I was in chemistry class when I was a kid, in high school when I was your age, so we had some in the back storeroom, and the teacher you just roll it around in your hands and kind of play with it and stuff. And I'm all right. But, maybe that's why I'm not as smart as you guys. Mercury vape.
Please don't die of mercury.
Oh, I won't. My exposure was long ago, hon. It's fine. Gas and fluorine and chlorine are gases, and we're going to learn when we get to chapter 12 why this is the case. Why some of these are gases, why one of them is a liquid and the other one's a solid. It's kind of interesting. Hey, you two back there in AP Chem. Has to do with IMFs. Yeah. I might. All right, noble gases we've talked about. We've talked about how their outermost energy level is full. And they were considered inert gases until the 1960s. They have found that a few of these can actually react, but it's a pretty kind of weird thing that goes on. And we can talk about that later. Well, it has to do with them using part of the D level to expand into. It's called an expanded octet. We'll talk about a little bit of that when we get into chapter 8. All right. The lanthanide and actinide series are your F block, and you know which is which because if you look at your periodic table, they begin with those two elements. So the lanthanide is the upper one, the actinide is the lower one, and those two elements make them up. The lanthanide series, most of the elements, one element of the lanthanide and almost all of the actinide are man-made. So 92 and above are all man-made elements. Or is it 93 and above? It's 93 and above. Sorry, 93 and above. Okay. So name two elements that may be shiny and solid and easy to cut with a knife and are highly reactive. There are three. Name two of them. What do we talk about? We're going to put them in water next week.
Sodium.
Sodium, okay.
Lithium.
Lithium and
Potassium.
potassium. There you go. So they wanted two out of the three. We named all three. Name the Name the element in row 5, group 2. Row 5, group 2.
Is it periodic?
Row 5, group 2. Strontium, yep. SR. Good job. Okay. Calcium, magnesium, and strontium all make compounds with chlorine and form CaCl2, MgCl2, and SrCl2. And bingo was his name. Oh, sorry. Name three other elements that could replace Y in this formula that would form similar compounds with chlorine. So this is going to be Y, and we've got Cl. We've got 2 Cl's to every 1 Y. We know that calcium did it, magnesium did it, strontium did it. What are those three elements have in common? In their location on the periodic table. Column 2. So another answer here could be barium.
Radium.
Yep. Is that R A?
Ra.
Yeah.
And
Huh?
then
Beryllium. Yep. There you go.
Can't pronounce things right now.
Okay. So all of those would form a similar compound, right? So they're all found in the same group. So they're going to form, remember Mendeleev looked and he saw the ratios. Okay. It's the same idea here. They're going to form the same ratios. And we're going to learn about how we figure that out numerically when we get into chapter 7. So we got some stuff coming to you. But right now, if they're in the same column, they're going to have the same properties. Okay? Same ratios. So name 3 other elements. We named 3. We're good?
Yes.
All right. Let's look at the we do. Name 2 elements that possess properties of metals and nonmetals. What are those things called that have both of those properties? What do we call that category, Ray?
Noble gases.
Nope. Try again. Metals and non-metals. They're both metals and non-metals.
Oh wait, no, I'm in the wrong section.
Okay.
Did you skip?
I skipped a we do?
Yeah,
Huh. I guess I don't have it.
because I have two we dos.
Okay. Well, give me a second. Okay, maybe I screwed up. Just hold on, y'all. Too much mercury when I was a kid.
Mercury.
Okay, so Ray was correct if we do the correct we do here. The correct we do says name two elements that are unreactive gases. Okay, so two elements that are unreactive gases, those indeed will be in the noble gases. And the noble gases are what elements? We need to name two of those.
Helium.
Helium, neon, argon, krypton, xenon, radon. And then there's another one that's new, but I don't know. It doesn't exist very long, so we just won't even bother with that one. Name the element in group 17, row 4. So what's group 17 called? What do we give that for a name? It's the name of the group 17 elements. I'm going to add an extra one in here.
What are the two elements with unreactive gases?
Pick any noble gas.
Okay, thank you.
Element group 17, row 4.
Iodine? No.
1, 2, 3, 4. 1, 2, 3, 4. 4. Row 4. What row 4 element?
Oh, row 4. Not bromine. Bromine?
Bromine. Yep. Row 4, group 17. That's going to be bromine.
Why did I think that?
All right. In the I do, CaMgSr form compounds with chlorine. Name 3 other elements similar to chlorine that we could replace with the X. So we have CaX2 here. What else could be in place of the X? Fluorine, bromine, iodine, astatine, and something else that we don't even know.
I'm a little confused.
Tennessean. What? Yep.
So magnesium.
So it could be magnesium fluoride. It could be magnesium bromide. It could be magnesium iodide. Because magnesium or calcium, if it was magnesium, it would be X2 here. So they're asking you what you could put in place of this X. We had chlorine there, so find anything that's in chlorine's column, and you could replace.
So
yeah.
Fluorine, bromine, iodine.
Mm-hmm. Yep. Okay. All right. Now I'm back to my we do. I need to fix this slideshow. Hopefully that'll be a reminder enough. All right, name 2 elements that possess properties of metals and nonmetals. We'll try this one again. What are these called that have metal and nonmetal properties? What do we categorize them as? That's 17. What do we call things that have properties of metals and nonmetals? Jersey. Metalloids. Okay, so these are called metalloids. Where are the metalloids located at? Where did I tell you the metalloids were located? Stair step, excluding. What did I exclude in that? Aluminum. So Al was excluded. So that's bromine here. Next to aluminum is silicone, or silicon, sorry.
That's boron on top.
Then we had germanium, and we had AS, TE. Next to TE is SB. So any of those would be the answer to number 1. Element in group 10, row 7. Group 10, row 7. Yeah, I'll just use the abbreviation. Some of those pronunciations are difficult for some.
Yeah.
All right, name 3 elements that could replace Z in ZCl3. And this is a little bit harder. So I will tell you that one of them is aluminum. And if you look up an aluminum here, you will see a +3 on your periodic table in this location. Yes?
Oh, okay.
So find another element that has a +3 charge in that location that is still a metal. It has to be a metal.
Gonna be a metalloid.
Yep.
Indium.
Indium. Yep. Gallium. So Indian, gallium.
Boron.
Nope, it has to be a metal.
Rhodium.
Rhodium. Yeah, probably. Yep, rhodium. So you get the idea. So you're just looking for another +3. Okay, and I'll teach you more about that when we get into chapter 7. Okay, that's just a preview of things to come. You're not going to let a question like this stress you out. Okay, this is just a stretch. I'm stretching you a little bit. Okay. All right, so you've got a little bit of time to work on your chapter 1 or 6-1 material. Okay.
Yeah, we have advisor today. So we
Yes, we leave at 33. Yep. So I'm giving you 10 minutes. You should be able to easily get it done in 10 minutes. There's not a lot there. Yeah, just Minga. I need to add in we do on here.